Introducing Traffic Buddy, an AI-powered platform for environmental sustainability, user equity, and customer convenience. So one of the major issues that many metropolitan cities like Beijing, New Delhi, Rome, and Paris are facing is air pollution, and it's largely due to industry carbon emissions, overpopulation, and most of all, traffic. So for example, the air quality index for New Delhi is 176 US-AQI, which is deemed extremely unhealthy by organizations like the WHO. While we may be oblivious to this in the West because we are considerably less densely populated, it's actually responsible for high rates of emphysema, lung cancer, and chronic obstructive pulmonary disease for millions and millions of people.
In an attempt to combat this, the governments have implemented the current system called the road space rationing, which provides a schedule on which days of the week a person can drive depending on the last digit of their license plate. This system is largely unjust, inconvenient, and inefficient. One person may be contributing to climate change more by driving their car a greater amount of times compared to another person, but both have the same traffic time. Also, a person may need to drive their car on a certain day, for example, for like an appointment, but their schedule does not allow it, as it happens to be on a day when all license plates cannot drive. Another important point to bring up nowadays is many people have found ways to get around the system, for example, by attaining another license plate. The inconvenience and inefficiency of the system is what inspired Traffic Buddy to come to life.
Traffic Buddy uses AI and machine learning system that uses PM 2.5 sensors to determine the concentration of pollutants in the air. PM 2.5 is one of the worst pollutants out there, and that's why we track it. Using this data, it provides a schedule based on the user preferences and the predicted PM 2.5 levels. It also takes into account previous patterns of emissions and based off of the user's previous carbon footprint. So let's do a little demo.
Here's a prototype of the web application of Traffic Buddy. So here's a login page and or registration page. First, we can click register here. Here you can put all your information. So your first name, your last name, date of birth, email, password, license plate, and phone number. Then you can click register here, and you're ready to log in.
And that brings you to the dashboard. So most likely the first thing you're going to want to see is your weekly schedule, so you know when you can drive. Over here, we've got the drive day list. So this is going to be calibrated by intelligent AI, which is based off of, your past driving schedule and your past history of emissions. But let's say something comes up. Say you have a dentist appointment on Tuesday and normally you wouldn't need to drive that day. Well, there's no reason to cancel like you would in the old system. Instead, you just go to request drive day, select Tuesday, and voila, the machine has changed it up for you. And now you can go to your appointment, no problem.
Next is weekly emissions. Here is a graph of basically how much the user contributed to climate change. You can see the days of the week.
Okay, so this is where we get our data from. So this is from our data set that has air quality data for a lot of places. So let's look at Hamilton, where McMaster is, and then here's a summary of all the data that we're looking for. The main data that defines pollution is generally the PM2.5 data, and we have data here that goes back until 2014. And let's download this data from here and download it as a CSV file. Okay, so here's our code for analyzing the air quality data. So we get the air quality data loaded into our notebook. This is the Hamilton air quality data. Let's load it up first, and then we can convert the date to an explicit date time in pandas. Let's take a look at the heading of the data. So here's the index. Let's get some regression results. So we want to get a different set of statistics to show us how well our prediction performs. And we want to predict for the PM 2.5 values. So now let's make a new data frame with the PM 2.5 column, and let's take a look at this new data frame. So basically, we're using the previous day's data to kind of predict the future, the next day's data. So what we're going to do is we're going to do some time series analysis. So here's what our data looks like. Let's split it up into training and testing sets. So 2014. So here this is from 2014. So let's say everything from 2014 is a training set, and then the test is the 2019 stuff. Let's take a look at the head of the training set. So this is all 2014. Let's import some useful libraries, and now let's test a bunch of models to see what's going to happen. So here we basically run this. We basically have a set of models. So we are doing linear regression, neural network, k-nearest neighbors, random forest, as well as support vector type of approach. And let's do some algorithm comparisons. So you can see here are the different metrics on how the models perform. Let's make a custom scorer. So we want to have a way to score which model works best. Now let's do a grid search on the different models. So here we want to basically do a grid search on the random forest regressor, which looks like it has a pretty decent spread. So let's do a grid search on the random forest regressor.